It's not an easy thing to conclude here. Why do I say that?
You can't see the other half.
You can't see the other half of them because the way they're lying, their hinge line is now parallel to the bedding surface because they've been knocked over. And so there's three reasons why you might not be seeing the other valve. It might be buried in the sediment underneath, it may have been on top and it's been eroded off recently, or it may have been separated. It is difficult to tell. Where you do see occasionally, you'll see them exposed a little bit further round in the vertical, and you do see them joined together. There's one over there sitting with its umbo pointing straight up, and it's joined together. So there's been certainly a bit of movement of sand. They're not in live position anymore. Now there's something else that lends evidence to them still being conjoined. So if they were separate, if you're going to say that they're separated, then the next question is, what's the separated valve's orientation? Are they concave up? Are they concave down? Is it even Stevens? Even if you're not going to say they're separated, what's
Most of them are concave.
Concave down.
Would anyone disagree with that? We've got some takers for mostly concave down.
That's pretty even.
I'd disagree with it. Because I think it's pretty even. Okay? Now that in itself, to me at least, says that they're probably still joined together. Because what position should they nearly all be in if they've been separated? They should be mostly concave down. Like you saw at Booty Booty. Okay, you saw I can't remember what the organism was there, I think that was a brachiopods, wasn't it? No, it's a reducted. I'm trying to think, it was something or other Barringtonensis. But anyway, it doesn't matter what it was. They were brachiopods, and they were separated, and they were nearly all concave down. There was a few sitting at odd angles, but 90% of them were sitting concave down. And that's what you'd expect if they're separated, because once they separate, sitting like that on the bottom of on the sand on the bottom of the sea, and there's a bit of current around, that's not a stable position. They're just going to flip over. Once they're like that, they sort of...
together, wouldn't they all be concave down because like both sides are round?
Yeah, but that's what I'm saying. But there's quite a few of them that are sitting upright. So they're both the valves in this case are that shape.
Yeah.
They're not going to sit like that if they become separated. They'll all flip over and they'll nearly all be concave down. Here they're not. So that to me says that they're still joined together. The reason you're not seeing them joined together is simply a feature of the way this surface is eroded. Okay? I know there's people around that would disagree with me. Judy Bailey, who you met last year, used to come on this trip a lot, and she would maintain that they're still conjoined as well. One of the original papers that described them here, though, says the opposite thing. Okay? So I think the evidence leans more toward them still being joined together. But certainly they've been disturbed, they're not in live position. Ron described the ripple marks, and you can see them here, so there's been movement of sand, so that's why they're not in live position anymore. They've certainly been jostled around, but these things had pretty thick shells. They would have had some pretty strong adductor muscles in them while they were filter feeding. So I think the bulb, on balance, it's probably safer to say that they're still joined together. What were some of our other questions? There's a question about diversity. Now we saw a couple of brachiopods, there's a few gastropods around. Did anyone see any borings? Yeah, okay. Again, the original paper that describes this, and I guess you'd have to have a good look around and probably spend a week here to find them, but they described these Eurodesma as being bored by gastropods. Okay, when you see that, it's a neat little, perfectly circular hole. Cylindrical hole. They drill through and suck the organism out, and it's the gastropods that do that. I can't say that I've seen any here. So that's that question. All you can do is write what you observe. If you didn't see any borings, just say exactly what you saw. So there were gastropods, there were spirifoids. What do you think the bulk of them are? What are most of the fossils?
Iridesma.
Yeah, most of them are probably 90% of what you see is the Iridesma. There's another little bivalve organism that sort of almost looks like it has fur on the outside of it, and it's a brownish colour. Okay. So the diversity is low. What about the abundance? So high abundance, low diversity. We struck the same thing at Mulbring last year, although the diversity there is a bit higher. But you've not got a big diversity here at all. What does that tell you? Yeah, so it's a classical cold climate fauna. Okay, and our ice rafted debris that's been dropped into this sequence confirms that, and we'll see some more evidence as we go down section of that today as well. What were our other questions? We talked about borings, we talked about the diversity, the orientation. What was that? What else? What have I missed?
Is there any evidence of mixing?
Yeah, okay, so that's sort of the wood question. Have we got, is all this stuff fairly close to in situ, or have we got material that's been dumped in here from elsewhere? Well, organisms dumped here from elsewhere. And it's pretty all close to in situ. They're not bits of wood, they're bits of slate. We will see, if you keep your eyes open as we go down section, you will see bits of plant material. Keep your eyes open. Okay? What have I missed? I haven't got the question here with me. So the nature of the enclosing sediment, that's something we're going to have to start describing in more detail as we go down section. What would you describe the sediment as?
Coarse grain.
Yeah, so it's quite a coarse sand. Very gritty. The preservation we didn't really do. So what are we seeing as fossils here? Are we seeing casts, mould? Are we seeing original shell?
Replacement.
Yeah, there's a few moulds around.
Replacement. There's some of the shells.
I'm no paleontologist. I was talking to Ron about this earlier. A lot of the Iridesma is probably the original shell. Okay, it's very fine grained. It's got a dark colour, and that may be related to sort of recrystallisation. These things, a lot of shelly fauna are the carbonates deposited as aragonite, which is metastable at surface pressure and temperature conditions. And because it's unstable, it tends to recrystallise fairly quickly. So it's probably recrystallised into calcite, but it's very fine grained calcite. Okay, and so some of that coloration may have, I think aragonite can have a lot more other chemical components in it than calcite from memory. And so they've probably been spat out and formed very fine grained dark minerals as that process has happened. So the carbonate's quite dark looking. Right up the top there's a question about the distribution of the rock unit. It's a pretty narrow, you don't have to go far up section to see no fossils, and you don't have, it's not far to go down section to see no fossils either, so it's in a fairly restricted layer. I think there's an answer here that says almost exactly that. Well done, Rachel. We talked about I think we've covered it pretty much there. Moulds, casts, original shell. So a lot of it's original shell. You do see moulds and casts. The spirophid that we saw over there is an internal mould. Worn or broken, yeah, there's certainly evidence of them being a bit worn, but they're still, again, I would maintain that they're largely conjoined. There's a question there about, is the sediment biodegraded? But can you see worm burrows and so on? You probably don't know what worm burrows look like. There's some up here. Here's some I prepared before. So sitting up here in this muddier looking sand up here, you can see these vertical burrows. Try and get up there. Where's Rachel? Yeah, tough. So this unit here, I mean, we won't start our stratigraphy here, we'll start our stratigraphy down the bottom. So sandy up to here, you'll notice here this rock's a bit darker, so it's got a lot of mud mixed in with it. Probably call it muddy sand. And towards the top of it, you've got these vertical burrows. So they're escape structures. You don't get the soft-bodied organisms getting preserved in this sort of environment, but you do see their traces. Okay, so that's what a burrow looks like. Keep an eye out for those. You'll be seeing lots of them during the day. And they can be a diagnostic tool for depositional environment. Okay, did we see any of those in the sand? No, probably not. It's pretty hard to see them in the sand in the first place. They tend to be mud. Ron's probably going to correct me here. They tend to be sort of mud dwelling. Depends on the organism, I guess. But that's what a burrow looks like. So that's a process called biotubation. So the answer to the question about biotubation, at least in the eurodesma layer, is no. I guess having said that, you'd need to see it in the vertical. But it's pretty hard to see burrows in material that's well winnowed like that. If they were there, they're probably long gone. Did you have anything to add, Ron?
Not about the paleoecology so much, but it's just a good example of one of the... Today, when we get into the measuring the section, we'll look for what we can describe are characteristic groups of rocks. We'll call them fascies, for want of a better word, since that's the geological term. This is one particular fascies that you will see multiple times during the day. And it's characterised by the coarse grain size, the lag, pebbles and cobbles and coarse sand, those bed forms that we saw there, shells, all that stuff together sort of sitting in a fairly restricted unit. We'll call those today, we'll call them transgressive sand sheets. And we just mention it here because when you get to start measuring your section, you'll basically be starting from that cliff unit over there, the very kind of steep cliff unit, and then we'll go underneath it down there. So you can't actually access that cliff when you get over there. So this is your chance to see what's in the cliff. As Bill pointed out, this unit here is about where that boulder is just about to topple off. And so there's another 1.5 meters, maybe 2 meters underneath it of this type of material. And when you get there and you look up to the base of it, you'll see that there's all these boulders and cobbles and similar material in the base. So this is where you get to see that stuff that's up there. We'll call it, we'll talk about this a lot more during the day, but we'll call it a transgressive surface of erosion, because when you get over there you'll see that what's underneath it is one of the other fascies that are called estuarine fascies. Okay? Estuarine fascies are back behind the coast. Marine fascies are out seaward of the coast. And so when the ocean moves landward, it's called a transgression. When it does it, it reworks all the material that's in front of it and erodes it away and leaves it as a lag, coarse grain lag deposit, indicating where the shoreline migrated through an area. So this is an example of one of those migrations of the shoreline through an area. This is what's left behind on the seabed after that transgression. I only mention it here just because there's a good opportunity for you to see this first one here, and then you'll see 3 or 4 more of them as we go through. Hopefully they'll look pretty similar to this one, and you can recognize them again as being this type of fasces. Okay, that's it.